Hi all, welcome to Clear and Concise. In this video series, I am going to discuss Andhra Pradesh Assistant Professor 2018 Mechanical Engineering question paper with detailed solutions. Let's have a look at this question. Which of the following is an explicit statement of Bayes' theorem? Among the given options, the correct answer is option D. This is the correct option. For detailed explanation, please watch the full video. In probability, event is outcome of an experiment. It's a outcome of an experiment. Task is an experiment. Okay, task is an experiment. The outcomes are head or tail. Occurrence of head is one event, or similarly occurrence of tail is also event. In probability, events can be independent or dependent. Independent events are those events where the outcome of previous event is not going to influence the result of current event. For example, tossing a coin. If you toss the coin first time, let's assume it as event A and second toss is event B. It doesn't matter what you got in first toss, whether it is head or tail, the probability of getting any outcome like be it head or tail remains same in event B also. That means the outcome of event A is not going to influence the outcome of event B. In both the cases, the probability of getting either head or tail remains same irrespective of the result of previous event. Those events are called independent events. One more example is rolling a die. It doesn't matter how many times you roll the die, the probability of getting numbers from 1 to 6 remains same, that is 1 by 6. So for independent events, the examples are tossing a coin or rolling a die. These two are independent events. For independent events, probability of A and B, that is A intersection B, is given as product of their individual probabilities. Now moving on to the dependent events. Two events are called dependent if the outcome of first event is going to influence the result of second event. For example, let's consider a bag which is having 4 balls where 2 are red and 2 are blue. If we take out one ball from the bag, now there remains 3 balls, among them 2 are blue and 1 is red. Now, if we calculate the probabilities for both events, in the first event, the probability of getting red is 2 by 4 or blue is also 2 by 4. Now, in the second event, the probability of getting red is 1 by 3 and the probability of getting blue is 2 by 3. We can clearly see that there is a change in probabilities because of the outcome of previous event. So those kind of events where the outcome of previous event is going to influence the outcome of current event, such events are called dependent events. For those events, probability of A intersection B is given as probability of A times probability of B slash A. This can be read as the probability of B given A. This is probability of B given A. It is called conditional probability, and it means what is the probability of getting B when it is given that the event A is already occurred. So what is the probability of getting B when A is occurred? This is called conditional probability. Probability of an event A is given as number of favorable outcomes divided by total number of outcomes. Now let's understand what does it mean by conditional probability, that is probability of A given B and probability of B given A. That means here B already occurred, what is the probability of A now? In the second case, A already occurred, what is the probability of B to be happening? These two are the cases. Let's consider first case, probability of A given B. For that, consider an universal set U where there are two events A and B. The common region between A and B is given as A intersection B. This is the common region between A and B. Now we need to find probability of A given B already occurred. So as B already occurred, take this event B out and redraw it here. This is B and the intersection region A intersection B. This is our favorable outcomes A intersection B, because in A intersection B only we have the possibility of getting A. So this is our favorable outcome, and here B already occurred. So this is our total possible outcomes. In order to find probability of A given B, we have favorable outcomes, that is A intersection B divided by B. Dividing numerator and denominator by universal set, we will have A intersection B by U divided by B by U. This A intersection B by U is equals to probability of A intersection B divided by this particular B by U is equals to probability of B. Therefore, probability of A given B is equals to probability of A intersection B divided by probability of B. Now considering other case, the second case, that is what is the probability of B given A already occurred. For that, take out this A and redraw it here. A, this is common intersection region, our favorable outcomes. So A intersection B is our favorable because A already occurred. This is our total possible outcomes. For that, we can write probability of B given A is equals to, again favorable condition is A intersection B divided by total A. Dividing numerator and denominator again by U, that is universal set, we will have probability of A intersection B divided by probability of A. By using these two equations, equation 1 and equation 2, we can write here probability of A intersection B is equals to, from equation 1 it is probability of A given B times probability of B, that is equals to probability of B given A times probability of A. This is known as Bayes' theorem of probability. Let's have a look at different forms of Bayes' theorem. This is the most simplest form of the Bayes' theorem. Here just now we have derived. Here instead of B there is Z. Okay, instead of B there is Z. The other form is explicit form. We can clearly see here everything is same as above, but the only difference is instead of probability of Z we have written some other expression. We will see what is this. Here you can clearly see that in order to get probability of Z, let's draw a diagram first here. This is A and this is Z, and this particular region is A intersection Z. Now in order to find probability of Z, this is Z. Let's say Z is equals to A intersection Z plus Z intersection not A. This is pure Z, not A, in the sense intersection of not A and Z is pure Z. Okay, we know this A intersection Z we can write as, from Bayes' theorem, like we can write probability of A intersection Z as probability of Z given A times probability of A from the Bayes' theorem here, plus similarly for Z intersection not A, this is also intersection, so probability of Z given not A times probability of not A. That is what they have written here. This is called as explicit form of Bayes' theorem. The most general form when there exist more than 3 dependent events. Here we have seen till now A and B, that is only 2 dependent events. If there exist more than 2 dependent events, then we can go for this most general form. Okay, these are the three different forms of the Bayes theorem. Now we have understood few basic concepts related to this question. Let's observe options. Probability of A intersection B is equals to probability of A by probability of B. This is not true because we have seen probability of A intersection B is equals to probability of A given B times probability of B, that is equals to probability of B given A times probability of A for dependent events. This is for dependent events. For independent events, probability of A intersection B for independent events is P of A times P of B. So this is for independent events, but they have not given whether this question is about dependent or independent events. They have exclusively asked Bayes theorem, explicit statement of Bayes theorem. We have seen like previous slide, which is written in terms of negation form, that is not a form, but here there is no such option, so we have to choose right one. So we can rule out this one also, second one, because here we don't know whether the event is dependent or independent. Now we can see the third one, probability of A given B is equals to probability of B times probability of B given A. This is wrong because here it should be probability of A times probability of B given A divided by probability of B, but this is wrong. Now here we can see probability of A given B is equals to probability of A times probability of B given A divided by probability of B. This is the correct one. Here we can see here probability of A given B times probability of B. Here in this option D, they have sent this B the other side, so it is divided by probability of B here. Now probability of B given A times probability of A, so option D is the correct answer.